Distinguished commissions, dear leaders, good afternoon. I am very honored to have the opportunity to give introduction about the works that we have been conducting in the past 5 years between PML and Southeast University. What about those achievements that we have made? Today my topic is pretty academic, so I would like to use English to talk in order to make it sound more academic.
Ladies and gentlemen, I speak English because my presentation is more academic. So for my presentation, it will cover 3 parts. The first part, so I will introduce very briefly the vision and some research background. The second part, there's a special technique. I will cover some information theory about the channel coding for the extreme low latency and meanwhile with very high reliability. Then the third part is about our experiment system to demonstrate this methodology is okay. It's very good, very best suited for the low latency, higher reliability communications. So because we a little bit behind the schedule, I will do my best to make my presentation short. So we start from the vision of the 6G. So I suppose everybody here is quite familiar with this chart. So in summary, the performance of the 5G will be enhanced by at least 1 or 2 magnitudes, as indicated here by the green dots in the chart. And in addition, there will be new features. There are integrated sensing and communication, integrated AI and communication, and ubiquitous connectivity. Ubiquitous connectivity means the integration between the NTA, non-territory network, and the territory network. So that's the whole picture of the situation. So this slide shows our testbed developed at the Purple Mountain Laboratory. So as you can see, so we can, by using this testbed, we can test a lot of key technology for the 6G, including the TBPS radio access, which mainly concentrates the terahertz wireless transmission, and the millimeter cell-free for the hyper reliability and low latency communication, and is a data-driven, and the AI, the platform, which is the foundation of the integration AI and 6G, and the cell-free for the UAV with some special future integrated sensing and communication. So this is the whole technical framework for our testbed. So first, I should explain the term DOICT. We call it DOICT. Here, D means data technology. O means operational technology. So the data technology and the operational technology will merge to the ICT to form the new architecture. So as you can see, it consists of 3 layers. The first layer is a core network, and we have an edge network, and we have an access network. We integrate the millimeter wave and the terahertz, which can reach the TBPS peak data rate. And we also include the sub-10 G frequency band. We can support very high spectral efficiency by cell-free architecture. The key feature, one of the key features is data-driven network digital twin. So by using this technique, so we can easily implement the AI inside the network. So another very important feature is TSN, industrial Ethernet TSN. You know, for the current 5G, there's no TSN. For our testbed, we integrate the TSN in the whole framework. So our purpose is to provide the deterministic QoS for the future. And the main focus of my presentation is low latency. So looking at the vision of the 5G and 5G Advanced and 6G, you can see that the low latency plays a very important role because it's very critical for the industrial applications. So according to our expectation, the latency will be reduced from a millisecond to microsecond. So at least 2 orders of the reduction in the latency. That will be very important for the industrial robotics and other kind of industrial applications. So another very important research direction is deterministic QoS, but it's not easy. So here is some key issues. So at least here, so how to guarantee the end-to-end deterministic KPI when the resource is limited, which means we should make very careful coordination between the different layers. The second issue is how to implement deterministic radio link. That's mainly referred to the link level. The third one is how to enable hyper-reliability, low-latency radio bearing that many consider feasible. So you can see the whole architecture is very complicated. For my presentation, we mainly focus on the small block length, because a small block length means low latency. And we introduced a new channel coding method we call spatial temporal 2D channel coding. So I will explain detail in the second part. And all the architecture is based on the reliable cell-free MIMO architecture. So I will refer this technology in the third part. So okay, so that's a background. So I quickly turn to the third part. So we should back to the channel theory for communications. So the channel theory says when the transmission data rate is less than the channel capacity, when the coding length become infinite, then we can achieve totally, completely reliable communications. But infinite coding means infinite latency. So the channel theory is impractical for our real communication system. Okay, so we come to the final block length. So we discussed 2 cases, the single input, single output case, and the multi-input and multi-output case. For the SISO case, so there is a channel dilemma. So which means you cannot simultaneously retrieve the very low latency, very high reliability, and very high data rate. For this 3 parameters, you can not simultaneously improve the performance. So that's a channel trade-off. But for the MIMO case, the situation will be changed because we added the new freedom, the antenna, the multiple antenna. So if you implement a very low latency system, and you can increase the antenna, because you increase the antenna can increase the data rate, can improve the reliability. So which means in MIMO case, very low latency, very high data rate, and a very high reliability is possible. For the SIO, it's impossible. So, because we introduce a new freedom. So here is some more detailed theoretical results. So you can see, so first I suggest you see the picture here. And you can see when the block length very small, and the reliability is very high. And you can see the trivial data rate can be very, very low. So we call it the capacity collapse effect. So how to mitigate this channel capacity collapse effect? So we can introduce the M. M means special degree, means increase the number of antennas, so the data rate can be accepted. So that's our conclusion. So there is a special temporal exchangeability, so which means the block length and the degree of freedom in spatial can be exchangeable. In this case, so we can achieve a very low latency and a very high reliability and a very high data rate by increase the number of spatial degree. Okay, so that's a theory. So how to implement the spatial temporal exchangeability? So that's the way we show here. So the upper figure is a traditional 5E channel coding method. So you can see for each data stream, the channel coding only performed in time domain, no spatial domain. So for the lower figure, so you can see we change the channel coding way. We coding both in time domain and the spatial domain together. So you can see in this case, you can reduce the latency but maintain the very high reliability. So this is a theoretical result. If you use a traditional 5 coding method, there is no spatial time exchangeability. But if you use a 2D coding method, there is a spatial and time exchangeability. So here is the performance comparison. So you can see that by using a 2D channel coding, so we can significantly improve the reliability. Okay, so the third part is our demonstration system. So a few words about the cellular architecture. Everybody is familiar. The main advantage is easy to be implemented. The disadvantage is if the density of the base station becomes very large, the system will be interference limited. So we come to the cell-free architecture. The main difference between the cell-free and the cell architecture is baseband signal processing. For the cellular system, each base station do the baseband processing isolatedly. No relation between the base station for the baseband processing. But for the cell-free, so there's a joint signal processing between the base station. So here is advantage. There is no limitation for the capacity when the density of the base station becomes high. But the disadvantage is the computational complexity. Because the computational complexity is a main bottleneck, so we should introduce some new architecture. So here is a new architecture. The baseband processing split into 2 parts. The user-centric processing part and 8 distributed unit parts. So in this way, when the number of user and the cooperative nodes increase, the capacity scale is linearly proportional increased. So in this way, we can avoid a very large computational complexity. So now we are considered to implement the 2D channel coding, which is based on the self-read system. So the whole the system is backward compatible with 3GPP standard. So this is a detail how to code the channel using the 2D system, using the 2D channel polar code. So this is our theoretical framework and our demonstrator for the sub-6G and the millimeter wave self-read system. So here is a result. So you can see the latency can be reduced by nearly 1 magnitude, but the reliability can be increased at least 2 magnitudes. So in this way, so we implement a RAISE system with a very low latency, very high reliability, and a very high data rate. So that's all for my presentation. Thank you very much.
Thank you, Professor Liu, Academician Liu. Next, let's welcome Academician of U.S. National Academy of Engineering, Khalid bin Latif.
All right, good afternoon, everyone. First of all, let me apologize. I lost my voice yesterday. I hope you can hear me well. So today, this is the outline of my talk. I'm going to be talking a little bit about the motivation for 6G, and I'm going to talk a little bit about the importance of having an AI native wireless network, briefly talk about edge AI, and then conclude by the use of satellite communication for 6G. So I thought I was going to start with this particular figure, which basically said that the wireless communication as we know it has been really affecting us everywhere, and the growth of wireless has been significant, dramatic. And what is clear is that mobile traffic is going to continue to increase at a substantial rate, in fact at about 54% from 2020 to 2030, reaching about 6 trillion gigabyte per year by 2030. But in fact, about 1/3 of the traffic is going to be in China. Now, what this really means is that 5G cannot support the future, and we need 6G by 2030. So I think we're here with an exciting time. We started with 1G around 980, moving to 2G, 3G, 4G, 5G, and now we are moving towards 6G by 2030, where I define it as we're going to have, instead of connected things for 4G, 5G, we're going to go to connected intelligence. And I think one of the things that is important is to look at the timeline. And I view that this release 20 is going to be important release, which will bridge the gap between 5G advanced as well as 6G. So in this context, there are two components. There is the release 25GA, which is basically going to focus on 5G advanced, and there is release 20 6G, which is going to basically initiate the initial 6G, and eventually is going to converge to what I refer to as release 21. Now, I think you've seen this many times, and I think what we know that there will be enhancement for 6G based on 5G, but there will be actually new features and these features will involve ubiquitous connectivity and so on and so forth. Specifically, 6G is going to have this interesting new paradigm. We're going to see seamless and pervasive integration of devices and network through a space, air, ground integrated network. We're also going to see something that is very exciting, is the integrated sensing and communication, where data transmission with environmental sensing integration is going to enhance the capabilities of localization and imaging. And finally, which is really going to be the key differentiator between the previous generation and the new generation, is the integration of AI and communication, which is going to optimize the network performance as well as enhance the efficiency through intelligent decision making. So right now, as you can see, there are a lot of activities around the world on 6G. So in China, you have IMT 2030, you have things in Korea and Japan, everywhere. And in Hong Kong, we have a big project actually trying to develop 6G. This is within a project that has been started in 2023. This is supported by the Hong Kong government, really to position Hong Kong as a major hub to develop 6G technology, and I feel privileged to be leading this particular project that started in 2023. At the same time, as you can see, there are a lot of activities with respect to summits and forum, and today we are at the 6G conference here, but there are many others in Germany, in Qualcomm and ICC in New York, but also there is what we refer to as the Hong Kong 6G Wireless Summit. This is a major event. In fact, it's the only event sponsored by IEEE Communication Society. And this IEEE Hong Kong 6G Wireless Summit has already been gone for 2 years. So this give you example, this is like 2024. We have distinguished speakers and panelists. And we're gonna have the new one, if you can read it well. It's gonna be 2025, is gonna be the 11th and 12th September, and we look forward to having many people attend this event. So now, moving forward, what's going to be different, what's going to be so special for 6G is this idea of moving towards what I refer to as AI native wireless network. And this is going to be a transformative paradigm shift for 5G. So in 2019, we had this paper where we introduced this concept of what I refer as AI-empowered wireless network. And I believe this is the first paper in IEEE that introduced this particular vision. And now there are a lot of things happening with respect to AI. And for example, there are actions to integrate AI into the radio area network from industry leaders like Samsung, like NVIDIA, Microsoft, and so on. And they have this, what I refer to as the AI-Run Alliance, which focuses on different areas. So this is kind of interesting to see things are happening not only from academia, but also from industry. Now, one of the things that is extremely important about AI right now, we always think about the use of AI for simply basically integrating it. But then AI and machine learning can be extremely important for resource allocation, which requires network optimization. And we all know that when we try to do resource allocation, you need to do some type of mathematical optimization, which mainly rely on what we define as very, very defined mathematical models. But then what we have been arguing over the past couple of years is that machine learning for resource allocation can be extremely important. It's going to be data-driven, thereby skipping all the models together, which are very difficult to do. So I'll just give you an example of some of the resource allocation problem. For example, multi-user OFDM, which is you can think of it as OFDMA, we're going to try to optimize the sub-channel bit and power allocation. So you need to do that based on optimization problem that we have done in our paper, the first paper that you can see there. Another example is how you can do, for example, the cloud radio area network, and you want to do some type of a joint access point selection where, as well as the beamforming design. Again, you can put that as an optimization problem and you do that, but in general, extremely difficult to do and because of the difficulty and the complexity of the problem. So in recent years, we have developed something through the use of machine learning in particular, we believe we were able to develop a powerful deep learning-based framework to solve optimization problems. Therefore, you can do resource allocation, and we have done that, and you have a reference here, based on the use of graph neural network and a technique, we call it imitation learning. Sometimes we call it learn to optimize. And what we basically can promise you is that if you can use this, you can actually make it scalable, and you can actually make it almost real time. As you can see here, first of all, you reduce the number of complexity dramatically, but you also reduce the time you do the optimization, which can make it real time. Now, this was in 2021, but recently we actually extended this based on something that is extremely exciting, based on the use of foundation models, that we were able to prove that you can actually generalize a lot of these, and you can actually come up with a unified approach, which will enable autonomous intelligent wireless network optimization. So this is a paper we have still a review in engineering, and I think this is a very nice piece of work that actually put everything together. Now one of the things I've been talking about very recently is this idea that when we start talking about the use of AI in wireless communication, I can guarantee you it's not trivial. It's actually very complex, very difficult. And so I believe that one way to address the challenges of AI in wireless communication is to use what I refer to as edge AI, which is an enabling solution that can address the challenges by basically trying to put everything at the network edge. And by doing so, you're going to be scalable, sustainable, and you're going to actually really provide low latency and very high efficiency. So one of the nicest things about edge AI is that I call it actionable. What do I mean by that? I mean it can seamlessly integrate data analysis and autonomous action locally at the network edge while responding in real time without relying on the cloud infrastructure. So there are tons of application things like, for example, for vehicles, for edge training, or for edge inference, a lot of things that we can do. And this is one of the people where we try to look into edge AI specifically for the Internet of Vehicles. Now, as we all know, I think, so you previously talked about Shannon, and all of us are familiar with Shannon, where we actually talk about really data-oriented communication, where we basically all you care about is how to communicate, how do I minimize the error probability, how do I maximize the capacity. But now with AI, there is something that is very important. We call it task-oriented communication, where basically we focus on achieving specific goals using metrics like inference accuracy. And I believe that by bringing together edge AI and task-oriented communication, this is going to be a transformative approach that will allow us to focus on what to communicate rather than how to basically communicate. And I think this is a very important area, and it's really, I call it transformative. Now, one of the other things that we've talked about is the idea of integration of communication and computation. So here I'm not talking about the integration of communication and sensing. And I believe that edge AI is going to play an important role in integrating communication and computation, particularly in environments that require low latency, high efficiency, and real-time decision-making. So on the left side here, we basically developed an edge learning framework. That's the first paper, which basically allows edge devices and wireless network to work together in order to train a global model while keeping the raw local data. All right? And then there is another thing that is actually very interesting, is this idea of over-the-air computation, where we try to exploit the waveform superposition of a wireless multiple access channel. And if you can do it correctly, this is going to be vital in order to allow us to do a model aggregation. And so this is also a very important, and this links in these two papers, we link the edge AI of how we can do that. The next item, which is also important, is the idea of integrating sensing, communication, computation. So this is very important, and we know that one of the key new feature of SIG-G is this integration of sensing and communication. So I believe that edge AI also is going to play an important role in this integration in order to enable real-time data processing, decision-making, and so on and so forth, and do it at the network edge. So here I have two examples. On the left side, we have basically developed a method that will integrate sensing and edge AI based on the use of multi-view convolutional neural network. And in fact, we use for this particular thing, use something called split inference, as well as we use over-the-air computation in order to do this. Then on the right side, we have what I refer to as the integration of sensing, communication, and computing, where we try to integrate everything, and you have a reference number 2. So there is a lot of potential out there in this context. Now, the last item I would like to talk about, I think this is very important. As I've mentioned, one of the 3 new features that will be available for SIG-G is this idea of ubiquitous connectivity, where we're going to see a ground, space, and so on communication. And I don't know why this is like this, but anyway, I think we are all understand that space, air, ground, integrated network is going to be very important in order to provide what I refer to as ubiquitous connectivity. And at the same time, there is also the possibility that we can integrate the space, meaning satellite, computing power, and network. And that will allow us to basically integrate communication, computation, and resources. So what I would like to do here, I'm just going to basically list some of the recent work that we have done in this context, where when we start talking about satellite communication, one of the big issues you're going to have to deal with is obviously privacy and so on and so forth. So what we did, we came up with something called satellite federated edge learning, where we try to basically download the data from the satellites to the ground station in order to actually use federated learning and try to basically do AI while keeping the data private. And as you can see, this is not going to be trivial, because the amount of data that you are going to have to download and so on, and you have to do it multiple times, is going to be dramatic. So one of the things that we've done to solve this problem is that we have come up with something called an inter-satellite link scheduling and satellite ground coordinated transmission, where we basically involve the network flow. It was optimized based on this satellite ground coordinating transmission. So this particular work has already appeared in 2024. Please, you can have a look at that. The last item I would like to talk about, I think recently we have been all talking about foundation models. So like GPT-4, for instance, and foundation models are extremely special because they are huge. You can train them, but once you train them, then you can actually use them for specific tasks. But one of the big problems for foundation models is that how can you, first of all, train them, but then once you train them, how can you tune these? So one of the things we did here, we tried to use satellite foundation models by leveraging the massive multimodal remote sensing data set for pre-training and fine-tuning in order to enhance the feature representation and generalization capabilities. So we believe this is going to be an interesting work. This is work we just submitted, and I think there's a lot of potential for using foundation models with satellite communication. So let me conclude here by saying that SIG-G is going to be so exciting, and SIG-G is going to be a transformative generation, which is set to basically introduce a revolution for wireless communication with unmatched speeds, ultra-low latency, and it's going to transform, in my view, industries, and it's going to allow real-time application, immersive experiences, and more importantly, and I think this is really going to happen, SIG-G versus 5G is going to allow the seamless integration of the physical and digital world. So with that, I'm going to basically conclude by a picture of our university, the Hong Kong University of Science and Technology. If you've never been there, it's a very beautiful place. You're more than welcome to visit us. With that, I'd like to thank you, and thank you for listening. Again, sorry about my voice. I hope it didn't bother you too much. Thank you.
Thanks, Mr. Harrid. 下面进入主题演讲的环。
Now we're going to start the keynote session. First of all, I would like to give the floor to the Vice General Manager of China Telecom, Mr. Luan Xiaowei, to give you a presentation. Well, he's going to talking to us about the 6G technological development and the China Telecom practice. Distinguished academicians, dear leaders, dear guests, good afternoon. Very glad to share with you our opinions and understanding of the development status of the 6G technology and our practice as well as China Telecom. Today I'm going to share with you three parts of my presentation. First of all, understanding of the development trend. Second is what China Telecom has been doing. Third of all, prospects in the future. In 2023, IoT has issued the suggestion paper for 6G, emphasizing that we have reached a consensus almost to 6G's development vision. Compared with 5G, we have richer application scenarios of 6G. It is going to transcend the information boundary and also having multiple elements combined into one. Also, ITO planned that by 2026, the end of 2026, a finished compilation of technology performance requirements and started the technological screening, and latest, we're going to finish the standardization by 2030. Also, in terms of the standard, this particular research of 6G-related technologies have been receiving a lot of attentions. 3GPP already emphasized that for the 6G roadmap or technology standard, we actually estimated that the very first version of this standard could be issued by 2029, and we've been reaching a certain consensus, including the AI native, integration of ground and earth, the integration of sensing and communication, XR, and also sustainability. Also, we do have other opinions by the other organizations. For instance, the GSMA or NGMA considers that the real cost of 6G standardization should be based on the commercialization needs, and also given that we might have a longer period of time for the technology to switch, so that we mentioned that while you're investing into 6G standardization, you have to protect the existing 5G technologies. Also, in terms of the potential technology, we are able to have the air interface performance tabs, and also believe that we're going to continue on the Shannon theory and further develop the spectrum development, and also having a real-time increase. Also, the technologies include the super large-scale distributed network of antennas, and also finally we are building a new architecture and also having ubiquitous coverage, and also the full region could be intelligent. Also, in terms of different country, every country has been focusing on the deployment of 6G technology. Europe, America, and Japan and Korea have also founded a certain industrial alliance, and based on their own advantage, they're actually doing a very good advancements. On the March of 2024 in the MWC in Barcelona, they have been showing their wonderful achievements. Also, under the guidance of the MIT, we've been initiating the IMT 2030 promotional group, responsible for the standard compilation and testing verification. Also, by the end of 2024, we have also been servicing 10 research papers and 7 original prototypes. So, now, please allow me to give you a sharing about the periodic achievements that China Telecom has made. Since 2020, we have been always paying attention to the development momentum of 6G technology. At the current stage, we are focusing on the new emergent structure, the integrated business of ground and earth, and also the integration of sensing and communication, and also the particular intelligent communication. And also, I think that this is the experimental tool for the national level key laboratories. And also, we've been building a very solid foundation. Also, we do have actually the other functions like the total promotion of the satellite ground operators, and also carry out technical experiments and applications, integrated air interface, and others. Also, we'll be making a lot of periodic achievements. And now, I would like to give you the detailed sharing of the latest technology and latest updates on the IoT NTN and NR NTN. So first of all, the direct link of the smartphone with the satellite communication is a new concept, and we have three models. The first one is that we actually developed this particular direct satellite business, and also you can see the dual mode, smartphones. We've got 25 different types of this kind. Second one is, we have to make the space communication and satellite very much supplementary, which is based on Starlink. And now we are providing the service to the full existing 4G mobile phone owners of the capability to connect directly with the satellite. Also, NTN as a new mechanism is believed to be a new operational model of 3GPP area, and also everyone should be responsible for that. Also, China Telecom has already deployed the proof of RNTN in terms of the narrowband communication. On 2023, September, we have finished the very first on-rail experiments in the ocean as a new scenario that is IoT NTN based. And also with the Tiantong satellite, we have been successfully commercialized this NR NTN network. And also on April 2024, in Zhoushan waters, we have already finished the high altitude 5 MHz NR NTN offshore. And also we have been finishing the MR NTN particular guidance, and also participated into the testing of the original prototype of NRNTN on 2024 November. So we have already finished the technological accreditation of IoT and NRNTA in LEO, MEO, and HEO. Also, it is the integration of sensing and communication. We have multiple ways of having sensing, and we believe that the base station sensing versus the particular base station terminal cooperative sensing endpoint, it is much more convenient and efficient on the left. And also I believe that the base station terminal cooperative sensing endpoint awareness could be improved in a much better fashion. Also, in this front, China Telecom is always a leader in terms of technological innovation. We've initiated the very first key laboratory research projects of 5G, of 6G, and also we have been dedicating resources, establishing the expert team of 5G-A, and also we pretty much promote this concept. And also we are trying to find the difficult points of integrating ground and the satellite all together. And also we have finished the highest scale of the low altitude field test and cover.
We started the low altitude experiment of sensing and communication. So we started the 3.5 gigahertz and 26 gigahertz millimeter wave to perform the zero cutoff of communication. Then network and network for AI are both the hot topics. For 6G, we hope that 6G can become the native feature for 6G, and we can realize the organic integration for both. For 6G, we hope the AI can enable the network to have higher performance, to evolve its performance and satisfy the efficiency. Then for 6G for AI, we hope that 6G can become the enabling platform for AI in the distributed computing and in distributed data and big bandwidth, low latency. We can enable different segments. China Telecom has actively been promoting the native technology verification. So we cooperated with ZTE and other companies to have the AI enhanced communication technology and dialogue and utilize that in cell phone. And in a wireless network, we originally studied the AI native wireless prototype, and in 2025 in Barcelona, we displayed the AI native RAN and mechanical guide dog. And in improving the performance of the network, we cooperated with Bale to establish a lot of synergistic experiments to realize the smart scheduling of the 3 places in the network for Huawei. And for future outlook in the space ground integration, we hope that we can have the high orbit voice, IoT, NTN, and NR, NTN, high bandwidth, and also the satellite ground and multi-orbit kind of synergy. And we hope that we can have the integration of the sensing and communication in the standardization of the base station sensing and the air interface technology for the AI and network communication. We also have several initiatives, and now we're cooperating with partners to promote 6G capability. In 6G, in the big platform of cloud and network, we already have the 8 items in experiment. We hope that partners from the industry or from the academic fields can participate with us to conduct the 6G critical technology R&D and verification. That is our understanding of 6G. We always hope to cooperate with the industry to innovate and explore the future for 6G. Finally, I wish this conference a complete success. Thank you. Thank you, Mr. Lan. Next, from China Unicom, the DGM, Hao Liqian. The topic is 5G refreshing the industry and the 6G restarting the industries. Distinguished academicians, leaders, and guests, good afternoon. We're happy to gather here with everyone in the beautiful city of Nanjing to talk about 5G refreshing the seconds and 6G restarts everything. So on behalf of China Unicom, I would like to extend to all of the friends that supported China Unicom the heartfelt gratitude. We hope that we can explore the boundary of the technology and build the win-win ecosystem of 6G. President Xi Jinping always emphasized on the importance of building the new infrastructure, for example 5G, to enrich the application scenario of 5G technology to speed up the new industrialization and the integrated development of high-tech and industry innovation to nurture the new quality productive force. And in the government report, it is the first time that it lists 6G as the core direction for future industry fostering. And currently, Premier Li Qiang said during the survey that while speeding up the scaled application of 5G, we need to accelerate the 6G standard drafting to consolidate the advantage, to have wider scope and deeper level and higher level of enabling. So we responded to the call of the President Xi Jinping and our country and government. We wanted to be the pioneer of the technical innovation, and we also expanded the connection and communication application. And we treated the scale development of 6G as our strategic focal point, and we developed the new plan for establishing the digital new infrastructure, and also the action plan for the digital and smart application, and also the guideline advices for becoming a strong digital and smart enterprise. So we built the highest scale of ship network. We already had 40,000 5G commercial projects and already 6,000 5G factories serving more than 16,000 customers, covering 80 different categories, promoting the deep integration of real economy and digital economy. In Jiangsu, we fully accelerated the new infrastructure building. Now we already have 110,000 substations 5G, and for the ISAC and high bandwidth business and red cap upgrade, we put in full swing the 5GA. And for Jiangsu China Unicom, we promoted the new productive force, and in Changjiang section, we established the first low-altitude smart connected network covering the channel of 98 kilometers of Yangtze River to realize the full process informationized and digitalized upgrade. And we realized the during voyage replenishment. And we also built the 5G network in Huaxing to assist the information operation, and we established the 5G super hybrid factory. So in strengthening and extending the industry chain for Yoda Guangdian, we also have the high accuracy positioning of the vehicles and things and people on site, and finished the Yoda Metaverse factory. So we will further explore the edge of 5G and try to improve 5GA. So we will focus on the 3 use cases and realize tenfold of improvement of the capability. And we want to build the downlink 1 Gbps to 10 Gbps and uplink 100 Mbps to 1 Gbps. And we want to realize the 10 billion connection and also the 5.9 high reliability transmission. And at the same time, we want to promote ISAC and also ground space integration and also the communication and AI integration to promote the merge of communication and sensing, to really have the direct satellite link on the cell phone to realize the new landscape. And we will further promote 5G and AI's communication to have the extreme service capability. And as the sponsor for Harbin Winter Olympics in terms of communication, while finishing the tasks, we use 5GA to enable the feast on ice. And for the first time in big sports event, we used the 26 gigahertz millimeter wave and 3cc carrier wave to realize the double 10,000 Mbps kind of level of bandwidth. And we also realized the cross network forming to alert for the unidentified drones on the in the designated areas. So for the Winter Olympics, we developed the cloud platform, and we provided services for the athletes as well as the audience in terms of IT service. And in the Winter Olympics, we also established the minute level of monitoring and the optimization plan generation capability to realize the network to be in perfect shape at all times. While refreshing 5G, we also want to innovate and try to draw the blueprint for 6G quality development. With the 6G demand, we had the 3 plus 6 plus 6, and we conducted the 6G study for the structure, and we promoted the 5G A and 6G integrated study to promote the breakthroughs in 6G and try to take advantage of our positioning as the leading central SOE and try to become the leader to lead the innovation of the ecosystem. We mentioned about the 6G sustainable sharing and the 6G network structure has become the consensus, and Tianyin simulation platform has become one of the 10 progresses of 6G in 2024. And we also developed the mmWave base station with our own IP. And we also established a lot of labs and alliances. We congregated many organizations and led the way of the technical development. Now, 6G is becoming a prototype and it's no longer a concept. And 3GPP is starting the 6G demand research and the project. In 2029, they will form the first visible 6G standard. So in that stage, we want to implement a new concept to innovate in employment, in operation, construction, and in commercial to build and operate the network to lead the new mode of 6G development. First, the innovation of the construction model. So to build the new 6G network, we will explore in the sharing and co-construction. So we have, in the past, the sharing of the network of the two operators. We want to go to multiple operators, and then we will coordinate with the ground and satellite as well. In the future, we will go towards the integration of sensing and communication. And we also need to take a look at the use cases of 6G. We don't want to be too wide and big because it's not differentiated. So we want to use the 1 plus N network structure. That means the one basic network with uniform standard and then plus 4 specific networks to fit different differentiated demand. For the vertical users, we can provide different choices. In terms of the frequency band, we will consider the synergy of mid, low, and high different frequency band, and the innovation of the the operation model. We continuously promote the deep integration of 6G and AI. We will use AI to improve the operation level of the network. We want to have the credible and shared innovation to build the blockchain-based data space, and we will realize the integrated operation to build the digital twin network. And for the network and product and resource, we can digitalize all those things and have accurate mapping and dynamic interaction in the digital twin to realize all network, omni-channel, all customer operation. Then, business model innovation to reshape the landscape. We will try to smartify the traditional industry and try to build the new blue sea for new industries. On one hand, we will use the edge AI inference to allow Gbps level of transmission to the understanding and low latency. We will try to use the technologies to enable development of the traditional industry. And second, for the high reliability and the coordination of the ground, road, and vehicle, then the satellite and cell phone integration, we can use those technology to generate the trillion level of market. And we know that innovation is the key for business. With AI enabling and API opening to the users, we can improve the user experience and try to release the business value. we want to use the open gateway experience in China to try to open up API faster to the users so that the API and the cloud service providers can co-build the ecosystem. We will strengthen our cooperation with the Zijinshan Lab. So last year we signed the agreement to build the collaborative innovation lab or innovation center. We will take the cutting edge technology as the target, and we want to become the source of the cutting edge technology to have the technical R&D and set the standard. So in the future, with the evolving 6G, we will use different innovations and integrations of different technical systems to make the 6G network more stable and convenient to realize flexible interaction of physical and the cyber world. And mobile communication needs to embrace the industry so that we can enable them to get involved in the standard setting so we can realize the chorus of 6G technology for all industries to establish the future of 6G connection. Thank you. Thank you, Mr. Then let's welcome China Mobile Chief Scientist, Ms. Wang Xiaoyun. She will talk about 6G-based wireless access network framework from C-RAN to SysRAN. So, dear academicians, dear experts, good afternoon. Just now, Academician Wu gave very good and important topics. To realize the commercial value of 6G, the architecture of 6G must have breakthroughs. So for China Mobile, 2 years ago, we had this end-to-end architecture proposed. So today, I would like to talk about the wireless framework architecture. So for the wireless access network, we have always been making innovations. So let's review from 1G to 5G. So for mobile wireless network access network, so actually we had this reproduction theory to the system theory. The past, it was single point optimization, then the collaborative optimization. For 1G and 2G, faced with a simple communication task, the single source or single point optimization, that means the distributed kind of architecture. So one receiving and transceiving, one processing. So it's highly segregated. And then with the development of the industry, this kind of distributed architecture faces the dual problem of efficiency and performance. So then collaboration comes the solution of the sustainable development of network. So in 2010, we, for the first time, mentioned the C-RAN architecture. So from the one connection to one processing, we transformed towards N connection to one processing, this kind of C-RAN of centralized plus the distributed. So we have 4C, the cooperative, centralized, clean, and cloud. And that kind of architecture supported the 3G, 4G, 5G development, and performance had been very good. Using this structure, we saved the cost for the whole Gezhou Dam nuclear power plant. So, especially on the edge side, we saved a lot of cost. And then, when faced with the 6G, of course, there are new challenges. So this is the 6G demand, 3 aspects. And for the access networks, there are 4 challenges. First, for the wireless access network, how do we make breakthroughs in performance? And how do we realize uniform experience? Second, in the past, for access network, the function was singular. It's just connection processing.
And this is a radio access network which emphasizes on the word access. But now we need to have something new. which is having a multiple way of providing service. And third challenge is that how that we are able to make sure that the capabilities are changing. And also, finally, everyone is pretty much notifying that with the limited bandwidth and also with limited frequency spectrum resource, how that we can make great and equal access. So also there are several challenges as well. But talking about also the architecture of the access network, how do we make a breakthrough? I believe that in the past we were talking about CRAC, and on top of that, we are able to emphasize on the cooperative capability and plus intelligence and service-based, so that we are able to have a new called CISRAN, which is SysRAN. This is a new kind of architecture. And why we need to develop on these three trajectories? First of all, taking a look at the cooperativeness. First of all, you know that if you want to have a breakthrough of the bottleneck of performance, the cooperative is a must-have pathway. So when we have CRAN, for instance, in the past, we actually migrated from a single-point MIMO to collaborative MIMO. And MIMO is a key technology when we march from 5G to 6G. And also in the past, we had the single MIMO, and now we are developing to a collaborative and a cooperative cell-based MIMO. But this is more than enough, because we still wish that we want to emphasize on our collaborative capability. In the past, it was pretty much cell-based, but now we have to have a wider scope of collaboration, which is centralized around the user, so that we are able to build a very good user experience. But what it is, this so-called network collaborative MIMO. Important thing is that in the past we have only single point access by only one base station, but we have to have multiple access now. Also in the past, we have to change from incoherent to coherent transmission. And also, most important thing is that in the past we only had actually the bordered, cooperation within BBU, and it should be changed to borderless. So that is the way for us to actually build up the always-on, user-centric collaboration and access. And also, we are going to realize a very good high-performance collaborative transmission and smooth and imperceivable switching. Also, for PML, we are supporting cell-free capability, and I believe that this MIMO is a very important key technologies to realize the cell-free MIMO. So hopefully that by having cooperativeness, we want to improve the performance. And also for 6G, I believe the very important thing is to improve the capability of multi-dimension, and cooperativeness is a very important key factor here. Also, in 5G, we are doing integration of sensing and communication. Most important thing is that sensing is the key part here. Also, in 6G era, we have to make sure that there is a multiple base station integration, and also integrating the sensing and communication all together. By having multiple point collaboration, can you have more synergistic effects, and also can you have more strength on the scattering? And also, by having a very good and also intelligent way, are you able to have the best development of the performance? So this is a very important thing. And also, we do have the new multi-dimensional capability, which requires cooperativeness. So if you want to have cooperativeness, you need to change a lot the overall architecture. So first of all, of course, that we need to have a high parallel and a higher accuracy. This is vital for us to get access to data, right? So we need to have actually a new capability of data sensing and data collection. Also, there should be a new way of the data transmission and delivery. In the past, we had the user data, but in the future, we might transmit and deliver the non-user related data. Also, the BBS and BBU might have a millisecond data dialogue. And most important thing is that on BBU level, we have to actually emphasize on a lot of other collaborative units, and these are all changing our practice. And another very important thing, as you have already mentioned, is the intelligence. And now we're having AI empowering everything, so that you can see that we can overcome the boundary of Shannon agreements, and also at the same time, for instance, the complicated algorithm and also the others, they all have the capability. And I think that we have been reaching to a certain level of consensus throughout the whole industry. So for all the higher education institutions, they've had the researchers covering the AI-empowered RAN, covering the whole kind of a suite of the journey. And China Unicom has been doing a lot of work in this area, and also, of course, just now, Academic Shen Wu mentioned that for the AF network, as for the mobile communication, a very important thing is that there is a restraint. This restraint is all about the latency requirements and power consumption requirement. So with regard to 30 different use cases, we conducted the analysis from top-down approach. I think that the requirement is actually different. So from millisecond standpoint to the millisecond standpoint to about 10 milliseconds requirements, and all the different requirements are different. I think that when you are performing AI-empowered network, you have to do it from top-down approach, from system standpoint all the way to the radio frequency. So I think that the most important thing, the first thing that you apply is on the system level. Also in the standardized organization, I think that they are already forming the energy consumption and energy consumption conservation related standardization work. So, of course, the first thing is that we will organize this AI-empowered research. So, for instance, for intelligence, definitely speaking, we are going to update our total efficiency. Let me give you an example here. As I have already mentioned, that we need to have multi-station collaborative MIMO, and now when we have more number of streams for this mathematical-based MIMO, we might have actually 10 times or even hundreds of times of more complexity here. So we can use the AI real-time inference capability, and also combining the AI with the communication knowledges, so that we are able to do the decoding and converting from n to the number of third to the O by the n. So for intelligence, this is going to be realized against the backdrop of collaborativeness. This is another point, right? But of course, with further development of technology, we are also going to further expand this to the whole chain and also whole link. And also, I think that our collaborative capability will further promote the development of AI. And you all know that the most important thing for AI is the algorithm and computational power of AI. And we will definitely share the data integration. And also, we are thinking that whether or not we should have another layer, which is AI collaborative unit in between, so that we're able to share the data more freely, and we're going to process the information by AI more centrally. These are something that we call AI-empowered network. Another thing is the RAN enabled AI. That means that the mobile communication, the AI is going to become a very important infrastructure here. And also, just now we said that the ubiquitous intelligence, right, as we have already mentioned, actually, RAN is something that is able to bring this sense of ubiquitousness to the user, because this is the closest to the user, and RAN is able to provide ubiquitous and low latency AI services to the users, and this is the best service nodes. And of course, we require a new guarantee of element convergence, and also the model delivery, and also most important thing is that it must have the terminal algorithm, terminal computational low latency performance. So it have a disruptive change on RAN itself, and also you need to consider the reconstruction of the process and also function. So in the past, these RAN has been processed by the core network, but now intercepted, and also you provide data service on the RAN level. So this is a big change, I believe. And that's why we are still discussing that whether we have to do this by step, or in one way. So whether it is the AI empowered RAN or the RAN enable AI, actually these challenges are many. First of all, we need to have additional layer. So previously we had NRU and BU, but now we have another additional RAN integrated AI unit, and also it should be responsible for the AI task control, AI reinforcement and training, and model management, etc. So there is a fundamental challenge brought just because of this restructuring. And the second and third part is the service. And also, you know that SMA and global carrier are actually promoting this service-based concept. But of course, that we have been introducing service-based SBA for the very first time by China Mobile. And of course, there is a fundamental paradigm shift. But still, I think that this is a very rigid structure, which is not that complete. And that's why we have been having a lot of difficulties and restraints now. So, to a certain standpoint, I believe that in the era of 6G, we must differentiate ourselves in doing the more customized service. On the RAN hand side, we have to change the structure or architecture from a rigid part to a flexible part, and we need to customize it. And also, there is a new issue that for different operators, they do have different requirements, and users are requiring different. So you need to make sure that your service delivery model could be as flexible as possible. Also on the RAN side, there is a strong coupling, and also the particular feature of low latency and a strong timing. And also there is actually a very good dilemma here. So, because of the difficulty and complexity of the service base, I believe that we have to do this on a gradual basis. First of all, we have to make the RAN capability open, because the RAN is a black box. Whether we can actually, first of all, make the API available to everyone and provide it as capabilities to others. Of course, in the 5G, the latency is quite big, so the limitation is big. But in 6G era, we hope that we can make it more accessible by the others because of low latency performance. And also the next step is still, we really hope that we can make sure that RAN is customizable and checkable, so that we're able to make sure that the RAN features could be API'd, and also we can provide atom level choreography also on the RAN side. But still, there's a lot of controversy here. So, based on these three requirements and also three directions, China Mobile has initiated the key national research project. The details will be skipped here. So, in total, we have been coming up and proposing the concept of SIS-RAN architecture. And by introducing the intelligence, service-based, and collaborativeness, we should, first of all, realize our key objectives by having a classified data collection and transmission, hierarchical aggregation, distributed intelligence, capability exposure, and service decentralization. Also, there are lots of details to mention. Of course, we believe that because of these changes of this particular architecture, a lot of complexity here, and we do see a lot of different challenges. So we do need people from walks of life to give us a particular work and how to have a breakthrough end-to-end, and to define the different interfaces and also different levels. Also, how that we are able to form a standardized path and rhythm consensus that not only meets the business needs but also adapts to global industrial development. Also, I think that NVIDIA and also the other vendors are also thinking about ecosystem establishment for the RAN, right? And so this is pretty much about the hardware ecosystem, and also on the application level, might be a lot of changes coming in, which used to be very difficult to innovate upon. So I think that we do see a lot of issues in these three areas, and we need to continue our effort. So we don't have a lot of time left for us, and standardization is on the way. So we hope that we are able to follow this direction of SRAM and CRAN, and to utilize our work, and hopefully we are able to have more standardized standards imposed here. So very grateful to have your support. Thank you. Thank you very much. This is a wonderful presentation. And now, next, we're going to have two exciting panel discussions. As you all know, that in 2025, this is actually the very first year for us to compile the standards for 6G. And also, we are going to march forward a very important task of disseminating the standard of 6G. So the topic of panel discussion is 6G technology and standard. First of all, I would like to give the floor to moderator Wang Xinghui, Vice President of ZTE Corporation, Board Director of ITU P2C, Vice Chairman of CCSA TC5, and also at the same time, we would like to give the floor to our panelists, Ku Wen, President of China Communications Standard Association, and Mr. Pandit Jain, Senior Principal Engineer and Senior Director of Technical Standards at Intel Corporation, 3GPP Chair, and Peter Schmidt, Huawei Expert, 3GP CD Chair, and Xu Taozhou, the Vivo Standard System Engineer, 3GPP RAN Vice Chair. Now, I would like to give the floor to Xinghui, please.
Good. I want to shake hands with you guys, but in the interest of time, I just skip this part, okay? So, good afternoon, distinguished guests, ladies and gentlemen. We go direct English. Welcome to this very exciting, just like the gentleman said, exciting panel of 6G technology and installations. As you can see, we're extremely privileged to these four big names of industry to be with us today. It's so great. I start with Mr. Waku. On my left, this gentleman, he's actually the chairman of the board, CCSA. I don't want to say what is CCSA. Everybody knows it, okay? He's actually one of the most influential guys in this global IC industry. And plus, he's actually my mentor of career. I was really inspired by his, super attitude and impactful professionalism. That's very good. So thank you for having you. Thank you. And next, Puni, talk about you, okay? Puni, we've been knowing each other for a long time. He's honorable chairman of 3BB TSGSA. And thank you, Puni, on good leadership. SA is in good leadership. It's good. Thank you so much. And Peter, he's from Huawei. He's actually the current 3BP CT chairman. And I would say CT is so lucky to have you with them. That's great. Last but not least, the gentleman over there, we've been knowing each other for years, okay? He's Xu Tao from Vivo, and he's currently the vice chairman of 3BP, another TSG, which is called RAN. Plus, you have been working at RAN 4 chairman for 4 years. Thank you for service for RAN 4, but now RAN needs you. Thank you for having you. After having this quite a brief introduction, I just want to go direct to our discussion about this 6G technology. I've been hearing about a couple of things on this 6G technology, requirement scenario, whatever things, it's great. But something came up into my mind is, what really brings 6G to us? I meant, is there something like a fundamental development philosophy to have 6G in terms of standardization? For instance, you can just dive in with kind of use case identification, or with some scenario pickup, or whatever things you're interested in, or even some to learn from existing 5G and 5G. So this is one question. I want to listen to you guys. First, start from Mr. Wang. Please go ahead.
Thank you very much. I prefer use Chinese instead of English. 刚才你讲到
So just now you talked about 6G's development. Actually, the main thing for 6G is that when we develop in 5G, what kind of things we still need to improve. We know that we have a very good 5G network, but the 5G network, as a lot of experts and academicians have said, actually the business carried on the 5G, still 95 or 90% are still cell phone. And of course, we have a lot of innovations. So for 6G, how do we let the 6G network carry the existing 90% of the business? What kind of other potential do we have? So maybe, let's not say much, maybe 30% of the business is not cell phone or not mobile terminal, but maybe industrial applications. And that is the most important thing. So this is about the vision of 6G.
Okay, thanks. Great. Now, it's your turn.
Thank you very much. So thank you very much, Chinwe, for the kind introduction. And I just want to take this opportunity to thank Future Forum and Purple Laboratory for this invitation. It's my pleasure to be here. Now, on the question about the philosophical, aspects of the 6G standards development, I mean, definitely there has been a paradigm shift as we talk about 6G standards development. So if you look at the 5G technology development or standards development and any previous generation, it was mainly performance driven. Now from 6G, what we see paradigm shift in terms of performance is still going to be important, but there will be also a purpose-driven network. And what I mean by purpose-driven network is, if you look at 5G, it was mainly about KPIs in terms of latency, reliability, throughput, and other aspects on the KPI. And network is driven mainly from a traffic and density perspective. From the 6G, we also can start see a focus from the human, machine, and society focus. What I mean by that is digital inclusions becomes important. So 6G would be seen as a technology that bridges a digital divide. AI augmentation becomes more important in terms of ubiquitous intelligence. And last but not the least is sustainability, which basically looking at 6G is a technology which is not just an energy efficiency from the device and network perspective, but also becomes technology that looks at the circular economy in terms of reusability of infrastructure. So that's how I see that, from a performance-driven aspects, the 6G starts to move from the purpose-driven networks.
Okay, so also from my side, thanks for the invitation, and I'm really glad we're here. I will try to not repeat what Pune has said. Let's try to add something on top. So regarding functionalities which are expected, not sure if this was said this morning. I've seen on one slide NGMN was mentioned. In NGMN, there was also a survey what the different companies expected from 5G. And there was also the major part there which was mentioned was AI and sensing, and also robot communication. And there were also things mentioned like virtual and augmented reality, and also smart home and smart cities, which will be really driven and giving more indications for 6G and advantages for 5G to 6G to introduce it. In this survey, it was also mentioned that some of these achievements could be also reached by 5G. So far to these expectations. And then regarding the 6G architecture and all these things. Here, for example, we had this workshop beginning of March, and here we had also a number of companies presenting their ideas about 6G. And there was also, in nearly every presentation mentioned, AI should be in 6G. So I was there seen as a driven part, and there everybody was also assuming new services. And one thing was also the reduction of the revenue. So the reduction of TCO was also one of the issues that should mention there. And there was also indications that the user experience should be improved. This was things which were mentioned there, and there was also an agreement regarding these in the system architecture group. There we have a requirement discussion, and there was a discussion to introduce a so-called AI agent. So putting all these things together, it looks like that in 6G we will have an AI agent in the network, and this AI agent will be then somehow control the network resources, helps to have the control over the network, and will also optimize and create services. And this will be, but it's still open how this will be achieved, and there's no clear guidance from these presentations during the workshop. Some said this should be achieved by reusing the 5G architecture, and others said we should introduce a complete new architecture. So this will be then the good discussions in the upcoming months and meetings to figure out how to reach consensus on this understanding of the future architecture of 6G. As a reminder, in 6G, in CPP, we are contribution-driven, which means on everything what someone wants to have, he or she has to write a contribution. And then we do not agree by majority or something, we always agree by consensus. And this is a big challenge to merge all these different understandings to one common understanding.
Yeah, thanks for invitation. Actually, as a newly elected Ron Vice Chair, it's a really my great honor to be here to representing TIG Run. So regarding the philosophy for 6G, for 6G development, I think I fully agree with our president when that we have to check what we have achieved in previous release. What's the takeaway from previous release to developing the 6G? I think at least in my view, one of the important takeaway from previous release is, I would like to say, this unified global standard. I think for 6G, we should recognize the importance of having such unified global standard, which we have already benefited from that by increase the scale of our ecosystem, we reducing the cost, we do provide the connection worldwide. I think that could be very important also in 6G time. We should keep that in mind. And somehow I also agree with Puni's side. I think besides all performance, of course, performance is a very important KPI in 6G development. But on the other hand, the purpose was also one of the driven part. At least in my understanding, one of the purpose is creating the value for this wireless industry. Value, at least in my understanding, not only the value for our operator friends, for the whole industry vendors, as well as the end users. So in order to achieve such value creation, the different aspects need to be considered when we're developing this detailed technology for 6G, including improving this end user experience, including the user, for example, the throughput, the data rate, to guarantee the user can enjoy our 6G network better than what they are did in 5G. On the other hand, we also need to consider the total the cost of ownership. By reducing the TCO, we can achieve much better profit or value for our operator friends. So although I think one of the very new concepts
for 6G is the sustainability. Nowadays, we have to developing our 6G in kind of the limited resources, including the energy, including any other resources. So I think put all this detail together, maybe that could be the part of this philosophy for developing our 6G technology.
Thanks. I'm really inspired by you guys. Actually, I did some note. Given you guys view the 6G requirements from different aspects, that's true, but I do see some commonality in your answers. That is, it's no longer a human-only thing. It is almost everything, human, society, machine, whatever. And just Peter said, we had a 6G workshop in Korea a few weeks ago, which I'll say I was there, I believe some other guy are all there. And the truth is, the view is quite diversified. We have different views. You can see I would say, optimized, I would say, let's say, conservative part. They are to protect something that you're doing right now, the incumbents, everything. And another side, we have just like an optimistic part, they are doing something much innovative. But on top of this, even in these quite diverse views, I can still find some commonality, which is AI. AI is almost was mentioned in every contribution in every company. So brings me to a second question. How could AI do something in 6G? My thought is, yes, we can see two directions. AI for 6G. AI can do something good for 6G, that's for sure. Just like Madam Wang from China Mobile said, AI can do something for this autonomous network, that's for sure. It can do something for the physical, for instance, do something like, reference signal reduction, whatever, it's good. And another direction, 6G network can do something for AI. For instance, we provide another plane. Let's call this airplane or whatever plane. It feeds the AI, or say, large language model with a bunch of huge number of data. Then you can train the model and do inference. Okay, this I would say conceptual two directions. The AI can interact with 6G network. So I just want to know your views on this. How can AI value something in 6G? Start with Wang Ku. Please go ahead.
I think AI it plays a very important role in the.
Oh, you're in English, it's good.
I'm sorry. Sorry, 我还是用中文说。
So I think I will still switch to Chinese then. I think AI is playing an important role right now because before there was AI, for a lot of work, we still need to write word by word. Right now, with the development of AI, we saw that AI has come into a lot of fields. In 6G, it undertook a lot of jobs, but I still want to, cut down on the passion. We don't want to be superstitious on AI. AI is like a child growing up. And before it grows up to be an adult, you feed him a lot of data and then he graduates as a doctor, but he only graduated as a doctor in the internet university. But if the AI wants to be like the tractor of the train, but if he's not trained, it cannot be like that. But if it has a foundation and it incorporates data of the tractor or the head of the train, then it can become the train. It's just like communication. So the metaphor means that in communication field, you talk about using AI, but when we use AI, sometimes we found that if you want to use it, from a general purpose AI to a specialized AI, there's still a big gap. You still need to have a lot of effort going in. So there are a lot of efforts going in this. I think in 6G, we are just starting. And what kind of effect can we get, I cannot say, but it may perform, but the standard drafters, the technical people, we still need to do a lot of work to make AI usable for us. So let's not talk about anything else. So in the CSE, we always say that we do a lot of repetitive work, wanted to use AI to make the standard, but when we actually apply, we sorted out the demand. We said, can we use AI for this, for that? But we discovered that for general purpose AI to the professional AI, we still have a long journey. So I think that's also true for AI. From general purpose AI to a 6G exclusive AI, we still have a long journey. That's it.
allow me a few minutes. I just want to have a follow-up question to my mentor, okay? What he said was basically, it's premature to count on AI on everything. Looks like AI is pretty much at a kindergarten or elementary school. It's not out. It needs time to get AI be ready to do something really good for business, okay? Which really shocked me. To me, I'm using AI a lot. Large language model, something I'm using a lot. And I heard a couple of quite interesting stories about different verticals using AI to improve their productivity, improve efficiency, a lot of things. But from this, I would say, quite, inside industry leader, I think this different. So, Mr. Wanku, if I may have a follow-up question. So, which means, in your views, AI is not that mature to do something really good for 6G. And also, when do you expect the AI to be ready to do something good for 6G? My point is, I'm sorry, I just want to make another thing is, AI is not that I would say that stable, that mature to do something good for 6G. But when AI will be ready, will be mature enough to do something good for our 6G, in your expectation?
Very hard question. I couldn't answer your question, but I think it needs a lot of things to do. And one example for the template of the standardization draft the paper. We try to use a lot of companies do this the standard. And the standard is qualified or not. It's quite difficult. We must ask people to inspect page by page. And it's really hard work. So I would like to suggest the CCSA use the AI technology to check the paper by paper by the AI. Only this is the small things. It's very hard to train the AI model suitable for our standardization inspection. So that is only the example. So in the 6G, we step by step, every area, we try to introduce it step by step. In the management, in the mobility and the network, the design, infrastructure, as Wang Xiaoyun mentioned just a few minutes ago. So many things. My philosophy is we should pay much attention in the AI, but we should not, I don't know how to say English, we do not 迷信，我们不能迷信 AI.
We cannot be over superstitious on AI. We could trust AI, but trust is not superstition.
In English, sorry.
We trust AI, but we don't count everything on AI, something like that. Thanks so much. By the way, I'm also vice chairman of CCSA TC5. Looks like my boss is talking to me. You got to do something in your TC5, see if it works. I got this, thank you. And please, I'm waiting for your Sherry.
No, thank you very much. I mean, as we know, like AI is taught today in every single things, and obviously 6G and 3GPP is no exception, right? So there is no talk today without AI, right? But essentially the question is, what exactly you can benefit out of this AI, and that's the million-dollar question. So when we talk about AI in 3GPP or 6G context, and we had this workshop, so like Peter mentioned before, like in 6G workshop in 3GPP, every single presentation talked about AI. Now, what we see is there are two aspects of AI. One is about AI for 6G, another is 6G for AI. So when I mention AI for 6G, it is basically about AI as a tool that will make 6G better. So this involves using AI algorithms and machine learning models for 6G infrastructure to do a better things that we have been doing before. Like, for example, intelligent network management and orchestration, which means intelligent resource allocation, predictive maintenance and anomaly detection, and using also AI for QoS optimization, personalized services. And in addition, basically using AI for security and trust, applying those techniques for better secure infrastructure. Now, also applying AI on the radio optimizations for channel estimation, modulation, and predictive algorithms detections. But we have to be careful when we talk about AI for 6G, because I think that is the question you also asked, Mr. Wenku. Because current communication model is a very deterministic. So we have all the algorithms which are very deterministic, which basically means like when you provide an input, you exactly know what is the desired output. But AI, when you are applying, is more probabilistic in the case. Well, it's more predictive in nature. So you are moving from a deterministic system to a predictive system, and the output is mainly driven from the probability of that occurrence happening. That's make it very challenging, because you cannot move a system from a deterministic to a predictive, because it can have a very undesired outcome. Even when you talk about a large language model, like let's take a ChatGPT and DeepSeek, I mean, sometimes you even put an input like what is the 2 plus 2, the result can be 5. And you cannot have that kind of undeterministic behavior in a communication system which has a lifeline of the many countries and have national security implications. So it will basically take time to get these algorithms matured and come very close to a predictive or deterministic behavior. So there would be always a notion of falling back on non-AI algorithms. So we have to be ready when the desired output is not what is being determined. We have to fall back on non-AI algorithms. We have to be ready from the 6G design perspective in terms of doing that. Now, the other aspects about is for 6G for AI, which basically means 6G is acting as a platform that enables AI. So when we talk in terms of communication system, AI is not a feature. AI is actually a workload. And what that means a workload is you can take as a large language model as a workload, and how effectively you can move the workload, which allows you to have the best utilization. So for example, AI workload can be very effective when you are at the edge or at the device as compared to always residing in the cloud. So 6G as a platform will try to enable moving of these workloads as a wide distributed cloud area network from device to edge to center office to a cloud. And that is what going to be a key, I'd say, use of 6G for AI. Thank you.
Thank you so much. At least one point, I just can't agree more. Communication is based on like deterministic theory. We have equation, we have mathematics. Why do we need a large language model to integrate from very beginning, from scratch? It's a waste of time. Yes, I totally buy it. And Peter, I want to know something from your point of view, something interesting and new. Go ahead.
Yeah, okay. Yeah. So the point is, this will be the interesting part in 6G to have these AI. How to use AI and how to make the 6G then really workable and be the best solution for the next 10 years after 2030. Because this is something we are talking about when we are doing now in the next couple of years the decision in the next 3 years. This will be something we have to live with in the next following 10 years until, if we continue like this, up to now we had in every 10 years we had a new G. If you see, you have seen these figures a couple of times today. And this will be now the big part to make the correct decision how we want to have 6G. Yeah. As said by Pune, I don't want to repeat too much what he has said. This is really the major decision what needs to be taken. What will be the best solution for the upcoming years? not only for the next 2 years, we have to do in 2030, we have to have the baseline for the upcoming 10 years. And as we have agreed earlier, within 3P, that will provide 6G the complete drop. So the first release, means with 21, will be a release which provides a complete set of basic functionality. How this might, I can have some estimations what might be the result, but this would be something which may be obsolete in 6 months. That's why I do not want to make too estimate here, because at the end you will tell me then next year or maybe just next time you have something wrong. This will be pretty clear, but at least this I want to really highlight the point that we need now a lot of active persons, that we come to a clear understanding how the future would look like. If something what we have seen here today might be one of the issues, but it's not clear if it goes like this direction, because in 3B we have currently 800 members. All of them have different views, so we can assume we have about 100 views about 6G. So which one will be the best one and which will be consensus, I personally will not do any estimate. I could tell you what the company I'm working for would like to have, but this might not be the one what you will end at the end. I know where Huawei is fighting for, but repeating this here may be not the correct case.
Great. My takeaway, you got a lot of work to do in CT to converge the views. Puri, you do the same. And Xutao, you will do the same thing, right?
Actually, I think from run perspective, if we try to limit this, my view in AI for run, somehow I kind of feel positive to it. As President Wen said, we are, AI is a baby. But in my view, maybe we are not in kindergarten yet. We are grade like 3rd grade or 4th grade. Since TH1 and also including THSA, we already spent 2 releases for this 18 and release 9 to study or try to answer the question which put out by Puni, how the AI can help the telecommunication. Or on the other question is, why, if it's needed, to standardize the AI functionality. Because in the very beginning, I think this question was asked everywhere, like AI is more like an implementation-based solution. Do we really need a standardized solution to support AI for network or for run? But I think after 2 release study, and also including 1 release like a normative work for 2 user cases, which is positioning and beamforming, at least through this 3 or 4 year study and specification work, I think 3P run has already identified several aspects need to be standardized or need to be specified to guarantee the AI functionality can be run more efficiently, or to guarantee the AI functionality can be supported in scenarios. That's very important. Since in our industry, we're not like a single vendor or like only implementation by single vendors. We are multi-vendor scenarios. So how this AI functionality can be supported for this in these multi-vendor scenarios? I think that's, at least in my view, I think 3P run or 3P has already identified several essential aspects to guarantee this AI functionality operating in these scenarios. But of course, it's not sufficient enough. For 6G, I think for 6G, we can start it from what we had already started for 5G time. Then we can take the outcome from the discussion and continue improve by selecting, I think as many other like speakers today, by choosing the different user cases, considering this commercialized, considering even the sustainability, to guarantee we design the 6G AI user cases can be better, serve our network, can better serve our customers. I think that's maybe a little bit positive, but this is what I think for this AI questions.
Okay. Irrespective of it's positive or negative, it doesn't matter, but it looks like to me oh, this guy from RAN, he drew the attention of the audience. He disclosed a lot of things in RAN, right? But to be fairness and transparency, I don't want a RAN guy be all on spotlight. So I have a question, dedicated for not RAN guys, but SA chairman, city chairman, on this architecture. Just like when from China Mobile just had a view about RAN architecture called CIS, collaborative AI-based S means sustainable something, okay? Which is different from existing CRAN or DRAN. And 6G core. We have different views, right? I know you guys are experts, so I don't want to jump into details. I have a question to you guys. So what's your view on this possible way of 6G core? Huli, you go ahead.
Thank you. So again, we take something from the 6G workshop, right? So we had a 6G workshop in March. And one thing which was very clear is that on the core network design, there is a very divergent view. I mean, from a conservative approach of taking a minimalistic changes and keeping the 5G SBI-based architecture intact with the minimal changes from a very revolutionary design. So there was a broad spectrum of views from different companies. Now, what I see is that from the overall design consideration, 5G core architecture was built as a service-based architecture, which was by definition a modular and extensible architecture. So the fundamentals are there to improve further from the 5 core. So I think from the 6 core network design, I think that concept of service-based architecture is very likely to continue. But then the question comes is what additional features or functionalities that can be built. And then obviously we have a lot of use cases from the sensing to AI and other different aspects from ubiquitous connectivity. So all those will add additional functionalities either as a new network function or enhancement to existing network functions. But other aspect I also wanted to talk is basically we have to do some learnings from the 5G system. And one of the learning from the 5G system is we had too many architectural options that we should try to minimize and let the complexity of 6G core network design. In 5G, we have a various network functions. So these net functions are now almost like 50 plus. And then you have these interfaces which are not really inter-vendor interoperable interfaces. Then the question comes is, do you really need these open interfaces, or there is a choice basically to collapse some of these, So that would also be one of the design consideration from 6G core network design, whether there is a need basically to collapse some of these interfaces, but there is a very strong push to reduce complexity. In fact, basically in the last plenary, we have endorsed a principle for a lean specification development. So what's meant by lean specification development is that, we should have a very careful and detailed analysis of the options, and options should only be specified when it's really, really necessary. Otherwise, we should strive to have a single option with a lean specification development. So these are what I would say is some of the considerations we need to take into account as we design 6G network, especially the core network architecture. But again, all these considerations will be further discussed in the 3GPP.
Yeah, I think I've said it already. This 6G core network will be a challenge how we will develop it in the future. The point is, this was also mentioned clearly in this workshop, that in principle, people would like to continue with 5G, some of them, but in parallel, the same people said we want to reuse as much as possible, said we want to have it simplified. And here we are coming really in a tricky situation, how you simplify something without changing it. So we need to do some changes. The question is how much changes would be best for us. Because as I said earlier, the point is not only to change something, to be able to change something. The point will be we need to change something that we are future-proofed. This will be the main part, and that's why we have to really, and this is the positive thing this time from 6G, we have now the complete RIS-20 to do study items, how 6G should look like, and how the protocols should look like, and what kind of protocols to be used. This is the main part of RIS-20. So at the end of RIS-20, we will have a good overview how the architecture should be, and how the interface may look like, and which kind of protocols to be used. And this will all give indications then, once we have a clear architecture, how the AI is put into this whole issue. Because as said all the others before, this is really an issue, what we want to do with the AI. And it was also said many times, AI, if AI influences the network and how to do something, means also this is based on collecting of data. And if we are collecting data, it's always the point, we have to be careful that we only get true data which are correct and well proved. Because otherwise, we are teaching a system with wrong data, and this will then end up in a nightmare. And then we are coming to the point which was mentioned by Puni, that when we are coming to the solution that we get a lot of wrong data, then we have to reset the whole system and start with the learning from scratch. And this is something, if this would happen frequently, nobody would be really happy with it. So these are the challenges. Sorry, I cannot give you any guidance how we solve this, but at the end, I think in 5 years I can tell you more about this, then we will have something agreed. But I'm positive on this because we always find a solution in the last couple of years. As long as I do standardization, when we had a controversial topic, sometimes it took some time, sometimes it was fast, but at the end we reached consensus. And many people were happy, or everyone was equally unhappy.
Thank you. I consider this chairman guidance. Any guy in this room, if you want to bring contribution to Jew panel, this is chairman guidance of CTNSA. Pay attention. Okay. And thank you guys. I mean, we have done a great job, and it's really great fantastic to stay with you and have this quite insightful, meaningful discussion. I want to keep talking with you guys at this podium, but there's a issue to catch up. The next panel, which is led by Professor Yu, it will be much more exciting. So it's time to say bye-bye, and we'll leave the stage for them. Thank you, guys. Thank you.
Now, the topic for the second panel discussion is industrial collaboration and also global ecosystem. So Professor Niu from Tsinghua University is going to be the moderator. So we have Sherman Shen, the former president of IEEE ComSoc, the former academician of Chinese Academy of Engineering, and so we have Tony Crack, the director of the Future Communications R&D program in Singapore, fellow of the Singapore Academy of Engineering, and professor at Singapore University of Technology and Design, IEEE fellow. We have Shigeji Nishioka, Secretary General of IMF Japan, and we have Menshon Kon, the chair of Global Collaboration Team 6G Forum Korea, and Matti Aho, head of a 6G flagship and professor at University of Oulu, Finland. Please.
Thank you for giving us such a good opportunity to have this second roundtable discussion. We will focusing on the global collaboration in ski research and development. I'm so happy to be the chair of this panel. As I'm Zhisheng Niu from Tsinghua University. Because we are heavily behind the schedule, I would like to ask our panelists to do me a favor. We are trying to shorten our. we were given 40 minutes, but if possible, we are trying to shorten into, for example, 30 minutes. Is it okay? And also, Marty, welcome to online. So welcome you. So hopefully we can have a very exciting discussion. Okay, so we will try our best to make our discussion short. Okay, so I do prepare 3 questions to each of you. I think we have to ship it, but because the time limitation, I want to shorten it, to compress these 3 questions into two questions. The first round, and we just very simple question, and I think for each of you guys, you can just use 1 or 2 minutes to introduce your national strategy or vision or the national programs, because you are the representative, the leaders in each country or region. We have the representatives from North America, Asia, and also Europe online. So first round, I would like to give you, each of you to self-introduce your national strategy or regional strategy or the wishes, please, from the Sherman.
Thanks, Professor Neil. So my name is Sherman Shen from University of Waterloo, Canada. So Canada is playing an active role in advancing secure, open, and resilient 6 technology. So through innovation, science, and economic development, Canada and other agencies, the country is fostering collaborations among industry, government, and research institutions to drive the development of next generation wireless network. So to enable 6G deployment, ISAC is innovating spectrum access solutions, including dynamic spectrum sharing and alternative licensing models to meet future capacity and connectivity demands. The National Research Council Canada is collaborating with industrial and academic partners to advance next-generation high-speed telecommunication technologies. Key focus areas include optical satellite communication, photonics, quantum communications, and the network metrology and timings position Canada at the forefront of 6G innovations. The many research groups in Canadian universities have been carrying out cutting-edge research activity towards 6G network development. For example, the researchers at the University of Waterloo are pioneering technology in enhancing 5G, 6G reliability, efficiency, and stability, while Carleton University teams are developing integrated area-based terrestrial communication architecture to expand network capabilities. Thanks.
Thank you. Thank you.
I'm Tony. So I'm leading this Future Comms R&D program for Singapore. It's the phase 1 started 2021. It's going to end in July 2025. It's about $50 million US investment. We are planning the phase 2 from 2025 all the way to 2030. Our vision is like, I think it's very close to what Purple Mountain Lab wants to do. We want to look at fundamental research, translation, test bedding, integration. The areas we are working on, we have been working on Open RAN for the past 5 years. AI RAN, we have established AI RAN lab. We started off last year. We are building also an NTN overall test bed. We'll be showcasing at Osaka Expo. And other 6G areas, we are a very small country, so we can't do everything. So I think it's a good platform. We can work with like-minded countries and agencies. Thank you.
Thank you.
Hello, everyone. My name is Seiji Nishoka from XG Mobile Forum. I'm a Secretary General of XG Mobile Forum, and maybe you are not familiar with the XG Mobile Forum, but in Japan, the R&D for the Beyond 5G and 6G has been led by the Beyond 5G Promotion Consortium established in 2020. But last year, this consortium merged with the 5G Mobile Promotion Forum to form a new organization, XG Mobile Promotion Forum, XGMF. XGMF is accelerating efforts in next-generation mobile technology, and we have right now is 22 active projects overall and 7 working groups focusing on wireless technologies. And our 6G R&D activities covers not only the development of the advanced wireless technologies, but also areas like AI-based network architecture and non-terrestrial networks and terahertz communication. What makes our approach unique is that we are also focusing on strengthening the real-world implementation of 5G across various industries. We covers not only 6G, but also 5G, so that's why we call it XG. So an international collaboration is a key pillar, and XGMF is actively working with ITU and 3GPP and 6GIA and NextG Alliance and others, and to align with global standards. We believe the strong global partnerships and cross-industry collaboration are essential to realizing the successful 6G future. Thank you very much.
Thank you.
Thank you for having me here. I'm Alex, and from Korea, and I'm working in a global collaboration deputy chair in 6G Forum. So simply, Korea is announced the K-Networks 2030 strategy. Under this strategies, we plan and execute in national program is to shaping the 6G. So major thing is 6G we define as structured into 2 key phases. Phase 1 is 2021 and 2025. It's mostly focused on the fundamental research and covering like a lot of hyper performance and hyper broadband, hyperspace sensor, intelligence and trust. So the key objectives to capture in 1 terabps data rate, and also supporting low latency at 1/10 of 5G, and expanding communication is at 10 kilometers above the ground. As phase 2 is starting already 2024 to 2028, as we shifting to the commercial phase, we already. And this covering in advanced wireless technologies and software-driven solutions, and beyond communication, and also the energy-efficient network with a resilient supply chain. So the key areas including upper mid-band expansion coverage, and also Open RAN, colleague, and AI-driven in the native core technology with energy-efficient component device as well. So we have 2 phases to fill the gap between the research and the commercialization phase. We plan 2 phases, a free 6G and 6G Vision Vesta demonstration event in 2026 and 2028 respectively. And also 2027, we plan to launch our aerial satellite with some testing about some antennas and modems as well. So also we expected, we always launch to the commercialization, so very aggressively as 2028 is we are targeting some commercial phase. So those what I can say.
Thank you. And Marty, can you hear us well?
I hear you very well. Can you hear me?
Yes, please go ahead.
Thank you, Sheng. So we started our 6G program already in 2018, and this phase will end 2026, end of June. We have been focusing on fundamental research aspects, technology enablers of 6G, and we focus on 4 major areas: wireless connectivity solutions, how the future RAN would look like, lots of research on hardware technologies, device and circuit technologies, ICs. Then thirdly, looking at this invasion of AI to all aspects of future networks and related services. And then the fourth one is looking at application and services within our 6G test network, which is quite the extensive effort, which was already launched in 2015, and at that time using 4G radios and lately 5G radios, and now we are putting some 6G prototype radios to be part of that. We are also looking at strongly some of the critical vertical application areas of society, as we believe that there will be some differentiation how networks are deployed to different vertical areas. And those that we are looking at are health, industry, vehicular, energy, and the fifth one is security and defense. After Finland joined NATO, there are lots of needs now to try to investigate different dual-use technologies and cases, so civilian technologies used for national defense and also broader societal security. As we are approaching the end of our current flagship funding phase, we have started to discuss internally a lot what should we do next. We have started to already brainstorm what are the next critical drivers and things related to beyond 6G. Since we are really planning, let's say, 6-year new funded program for the next phase, and there are maybe 3 different key areas that we have identified so far: resiliency, sustainability, and these implications of AI, and all of these from societal perspective. So we are considered to look at more like societal needs than technology push, which has really dictated and guided us mainly so far. And I would like to share a few ideas related to this resiliency, which we see extremely important. Natural catastrophes are happening more and more frequently all around the world due to climate change and other things. There's also increased cyber threats in modern societies, and now, unfortunately, in Europe we have also ongoing war. So all these things cause challenges for the resilience of mobile networks in the future. The bigger problem even is that these different parts of critical infrastructures, they are interconnected. For example, power grid and mobile networks, they are tightly interconnected, include also GPS, which is used for synchronizing these both. So all kinds of different systems, they are interconnected. The key question for the future needs is how can we make any of these future systems more resistant to failures and make them self-correcting, self-adapting to something which is unplanned. And we do believe, for example, that AI-RAN-related solutions is the key technological platform for making it happen in practice. Lastly, there are different major funding schemes in Europe and Finland related to 6G research. Our national flagship program is really massive. It's about 250 million euros for 8 years, ending next year. Nationally, we have also a business funding, so-called 6 Bridge program, which has a budget of about 150 million. It is ending end of next year. They are currently funding about 30 different projects, and then at EU level, we have 6G SNS program, which has currently 62 projects, either ongoing or finalized, and with a total fund of 380 million euros. And one of the examples of this EU project is HexaX2, which is ending in 2 months' time. So with these words, I would like to conclude my short introduction.
Thank you, Marty. I think from the introduction of each panelist, we understand that most of the country or region, in fact, we are sharing almost the same vision or strategy for 6G, but we do have different countries have different priority or different focuses. So that's good. I think this is why we need a collaboration, right? So now let's move to the second round discussion. Looking back, I think global collaboration has been playing a very important role in the R&D of mobile communication networks. resulting in fact eventually we got one single unified standard for in 5G era. Before that, before 5G, we had 3 or 2 standards, but now eventually we got a unified global standard for 5G. But for the 6G networks, shall we expect the same trend or the same, or if yes, what kind of collaboration should we pay more attention on this, global standard? And what are your expectation on the global collaboration, and what might be the key challenges or the main barriers in achieving this goal? So this, I'm sorry, this is a very complicated question, but maybe a tough question, but I do want you to share your opinion with us. Yep, start, Sherman, please.
Yeah, thanks for the question. I think you combine both questions. Yeah. So the international collaboration at all levels is critical to successful 6G R&D. So at the national government level, Canada has partnered with many countries in launching a joint statement of principle for 6G, laying the foundation for the next generation of wireless technologies. The industry and academic collaboration is becoming more important for 6G innovation, especially for the cloud AI for network management, which requires large scale of computing resources and substantial wealth of data and knowledge in network optimization. For example, the collaboration is necessary for technical innovations to develop customized large language models for network management and optimization. The collaborations can be multi-faceted, including public-private R&D consulting to co-develop foundations technology, for example, AI-native networks, alignment of academic research with industry roadmap through the shared testbed and standards contribution, for example, through PPITU, working group, etc., and the talent and knowledge exchanges. So answer the part of the second questions. At the Canadian leaders in 6G research, we strongly believe that international collaboration will be foundational to the success of the 6G networks. Our expectations are shaped by the belief that 6G will be more than just a faster network. It will be a global infrastructure that underpins everything from immersive communications and the intelligent system to sustainability and universal connectivity. So our expectation for global collaborations are rooted in 3 imperatives. Interoperability, so a unified yet flexible framework that harmonizes AI-native networks, quantum secure protocols, and terahertz spectrum across borders. Ethic consensus, so shared government models for AI ethic, data sovereignties, and environment accountabilities to prevent race to the bottom. Inclusive innovation, so ensuring developing countries and marginalized communities co-design 6G, not just consumer. However, achieving those expectations face some critical barriers. One is that geopolitical tensions and the technology fragmentation. So the rising geopolitical divide risk splitting the global tech ecosystem, leading to competing standards, duplicate efforts, and the loss of interoperability. The second one, the data sovereignty and the AI governance. So differences in regulation on data privacy, ownership, and transfer can limit collaborations on 6G technology. The third one is standardization, timing, and fragmented contributions. So the race to lead 6G can sometimes lead to uncoordinated submission to standards bodies, risking misalignment and delays. So we strongly recommend better pre-standardization coordination through research roadmaps, joint white papers, and shared reference architectures. So this can be achieved through global collaborations. The Global 6G conference here is an excellent example. Thank you.
So I'll try to summarize the points. I think the first point is we know likely all this new architecture network 6G will be cloud native, which means that you have to go beyond a 3GP RAN, involving, for example, other organizations that have done cloud or standardization for an foreign alliance. There's so the challenge and opportunity. If not, there's a duplication of work. So that's one. We talk about a lot of AI native network or AI native. So there is a lot of opportunities which also have challenges, particularly we see because it's going to involve architecture and hardware, which clearly, because of geopolitical, accessing of hardware for certain countries, for example, China, will be difficult. How will you influence that part? And together with standardization, that is a very complicated game, which currently will change the way different countries want to push their AI native network. I think the third is also opportunity in the sense we talk about green native network. It will have to go beyond influencing our 3GPP. That means a lot of sustainability work has been done at ITU. Going beyond a comfort zone to there so that some of the criteria metric can be also influenced the global stage is important. The last is related to collaboration, and as what Professor Chen has mentioned, because of geopolitical situation, I think the role of where big countries can play is how do you bring small countries, for example, like Singapore, we like rule-based open systems. How would small countries which wants to play in the rule-based get involved in all this as to contribute at least a small part? I think that's my take. Thank you.
Thank you.
Thank you very much. As Professor said, that looking back, international collaboration take a big role in 5G, and it leads to one single international standard. But at the same time, that the infrastructure rollout and investment cycles have been delayed, and many countries haven't yet seen the full value of 5G, and monetization remains still a major challenge in full 5G. So to keep the investment flowing, and we need to identify shared national priority earlier. To do that, we need to align internationally for the priority and focus on our efforts on the right technologies for standardization. So for both 5G and 6G, it's vital to build a global agreed values and like robustness and high performance and wide area coverage and energy efficiency and mobility. And that leads to the good future for 5G and also for 6G. And for the challenges, what we see is that we think two things, that collaboration between the industry and also the academia is a good, it's a big point to lead to a successful 6G. That's one point. And also that the difference in each country's guidance, like say security and on other rules in each country might be barriers to 6G international cooperation. Thank you. That's it.
Thank you. Alex, please.
Thank you. So I want to start with some common understanding. So global corporations has been the kind of cornerstone of mobile communication R&D, and which lead to the successful of mentioned is a global unified standard of 5G. So this is collective effort actually has accelerated the international cooperation and global interoperability, which those make some opportunity for the large-scale deployment. So those trend, I think, is expected in the future as well. So combining this question, I briefly bring up the key point on opportunities for the cooperation together. There's firstly standardization and spectrum harmonization. That is the remain must the first option. So we need to collaborate on these spectrum allocation and also to make a unified framework to through the 3GPP and ITUR to work together. That is to prevent about the fragmentations, and also we could make a more global applicable interoperability situation. And second could be the joint R&D initiative. It should be strengthened between the government and the industry academy. That always accelerate some breakthrough in the time of AI-driven networks, also terahertz communication, other cutting-edge technology being considered. So that's the second. And secondly, cyber security and supply chain trust will be crucial for 6G as well. So we need some global accepted the security framework we can think about. And finally, the sustainability and some digital inclusion should be prioritized, and we need to share important vision together. So it's the opportunity we can work and make it bigger and good technologies. And on the contrary, if we look at some expected roadblocks ahead, we have a geopolitical and the regulation issue. To be honest, the countries, different country nation policies and security concerns nowadays making more, the situation is tough to agree on some spectrum and other unified security framework. That we need to think about, You're right. Cut through it through the more open communication, and we need to build some genuine trust between countries. So this is the number one thanks to the challenges. Second, probably IP is intellectual property and some competition challenges between countries. Yes, we all want to cooperate, but actually companies and countries are naturally protective all their innovation. So the time, how do we find some sweet spot to between like protecting the own the IP, also we enabling some open innovation environment. That is the second one. And third could be cybersecurity and other data privacy management. This is becoming more very urgent. And as our networks get more intelligent, so without global agreement on security standard or regulatory privacy regulation, concerns about the data sovereignty will keep creating our barriers.
Thank you.
We already seeing this already, right?
Yes.
And lastly, we need to acknowledge some asset gaps between countries. Not all countries invest equally in 6G, right? So we need to think about how do we make some more public-private partnerships. Also, how do we make a better international funding schemes to make sure everyone can participate meaningfully.
Yeah.
That's all.
Thank you. Thank you. Very nice. Marty, please.
Thank you. So lots of good points already stated. I will try not to repeat those. I agree with all other previous speakers. But what I can say that in Europe, we have a tradition to have lots of different European Commission funded cross-national projects related to critical technologies. And for example, in 6G, we had already lots of different projects. And for example, this HexaX is the most well-known. The current one has over 40 different partners in the project. And the role of those projects is very important because different companies, competitors, they build common visions and views on what are the key technologies for the next generation mobile system. They don't need to agree about those things, but they are forming, let's say, mutual understanding how different things are seen by other players. And this tradition has been ongoing since the development of 3G already, with really great results. And now the research phase of 6G is coming to an end, and now the standardization is starting, as we saw a few weeks ago in Korea. And still, the ITUR Working Party 5D report on 6G requirements is ongoing, and I would like to encourage everybody to look at what is written in that draft proposal, if you can get that draft to see it. And I have seen it, and one thing which makes me a little bit worried about, there are some commonly accepted buzzwords in that document without really anything concrete how to address that. For example, sustainability is mentioned there, but very little, let's say, KPIs defined for it. Another one which is now for us quite critical is resilience. Resilience is mentioned, if I recall it right, 5 or 6 times in the document without any concrete suggestions how to address it in the standardization process. Whatever might be your critical interest area, but now it's the right time to try to influence on the development of 6G requirements through your national contact persons who are participating at ITUR work. Then how to have more international collaboration. I think these types of events are of great importance, and researchers, I think globally we share very much similar views on what are the critical technological choices for the future. More flexibility in terms of using spectrum, more flexibility on how the network should be configured, more AI here and there. Of course, it doesn't come for free, and we should look at also how can we, for example, maintain energy efficiency whilst introducing these really fancy new technological approaches. But anyways, ITUR has already defined these 3 new corners: integrated communication sensing, putting AI to be in a key critical role, and ubiquitous connectivity. And the ubiquitous connectivity is kind of it's important and interesting new direction that should be addressed more. And one of the interesting questions is that how might satellite communications be finally merged to be part of the BGPP solutions? That will be very interesting to see. I'm not sure if everything is mature enough yet to make that marriage happen, but eventually it has to happen. So these are my thoughts on this.
Thank you, Marty. I'm so sorry I have to stop here. So although our discussion was so exciting, and we do learn a lot, but I have to stop here. And I'm so sorry and also thank you for your very cooperation to make this. And also I apologize to the audience that we couldn't have any time for free discussions. So hopefully you can catch the panelists if you have any questions after this this table. So thank you very much again. Really appreciate it. Thank you. Now.
接下来我们将是今。
Now we are having a very exciting announcement section of white papers. So this area, the people from industry, academia, and also research have joined efforts to come with a lot of great achievements. And every year we are building this platform for everyone so that we are incorporating these achievements into white paper so that it's going to be benefiting the humankind more. So next, we are going to have the release of white paper on the 6G related technologies. Now, first of all, we would like to give the floor to Wei Hong, chairman of mmWave Working Group of Future Forum, chief professor at Southeast University, IEEE fellow, to release the white paper on 6G mmWave asymmetric large-scale array architecture. Hello, and dear experts, hello to you all. Let me share with you this particular white paper on 6G mmWave asymmetric large-scale array architecture in about a few minutes. If you're interested, take a look at the details later. I'll briefly introduce this architecture and also the evolution trajectory. Well, we all know that from 1G to 3G, we had actually a single-out system. In 4G, we had MIMO introduced, so that we had actually a additional dimension on the spatial reuse, which is going to increase the scale a lot and the capacity of the system. And also in the 5G, we had the massive MIMO array system introduced. But what's shame is that in 5G, this is actually a kind of a hybrid structure, and also the fixed beam generation. And there are a lot of disadvantages naturally. So this is actually a trade-off between performance and the complexity. So this should be also regarded as a transitional technology as well. Actually, for the best architecture, it should be a fully digitized, large-scale array system, an architecture, which is able to have a very precise phase control, and also can generate dozens or hundreds of different beams, and also the capacity of communication is huge, and every beam can also have their array as well, and it has its own different features, but still there is bottlenecks of the processing in real time of massive high-speed ADCs. So in order to cope with this issue, we in 2018 proposed a new architecture which is called asymmetric, fully digital, large-scale MIMO array system. So this particular kind of array, the receiving and transmission arrays are different with different scales. So for this architecture, on one hand, this is actually having the performance for symmetric and fully digitized system, but also this could help to reduce the overall cost and also power consumption. From 2000 to 2004, with the support of the National Key Scientific Research Foundation, we had a series of proof already finished, indoor, outdoor testings, and all the others. So all the performances are actually pretty much tested, and also this was much better than the hybrid beam generation technology of 5G. So for this white paper, there are many different institutions joining us to compile. There are too many names, and I will skip the details of those names. So, without further ado, I would like to invite the representative of those organizations that are part of the compilation process to be on the stage to witness the release of this white paper, please.
感谢洪伟教授，祝贺毫米波工作组的各位专家。
Thank you, and congratulations to experts. Next, we will invite the 5G6 Work Group Chairman of Future Forum and the Chief Scientist for China Mobile, Zhiling, to release the 6G White Book.
Wait. Do you want to stand up and stretch a little bit? It's a long day. I have a collection of great fruit labors from our team in our community, and originally was planning to share it in a 20-minute slot. Now it's told that we'll have to try to do it in 10 minutes. So let's see how we can fly. Okay, next page, please. Oh, I can control it, sorry. Yes, okay. Well, this is our community, this is all of you, 50 plus organizations. We together set up the 5G SIC in 2014, and then in 2020, we converted it to 5G 6G SIC, and together, over the years, starting from the very beginning, rethink the fundamentals, green for efficiency and soft agility, to moving on to the ICDT convergence, adding open and smart into a combination. Every year, jointly, your fruit and labors are shown here as evidence. So this year, no, this was last year, we had our 10th series with 20 white papers together. And this year, oh, sorry, I just want to say one thing, which is echoing, I guess President Wu has left, but I want to echo what he said. From 1G to 4G, we were actually focusing on single track, which is our communication technology. And from 5G on, as is shown, cloudization, virtualization came in, and basically it is the beginning of the ICT convergence. And then from 5G on to 6G, we are looking at a true and deep ICDT convergence. And this page was in my deck of our first global 6G conference when we released the first white paper of 6G. So is the next one. So as you can see, from ICT convergence, which is afterthought for 4G, but native in 5G, to ICDT convergence, which is afterthought of 5G, but it's native for 6G. I think our effort in the past 5 years have proven this has been truly the path, truly transformation journey that we are undertaking together. Again, this is a page from 5 years ago, 2020. We released our first of 6G white paper. And this year, we are very happy to say we don't have 20 white papers, but almost we have 19. Okay, again, an umbrella white paper together with 18 topical papers, white papers. And also, very specially, I want to share with you the fact that this year, in our SIC, we have established 2 task groups. One on ISAC, the other on network architecture, because there has been a lot of interest, a lot of effort in our white paper collaborations here, and as you will see. Actually, I highlighted in yellow, there are 3 topical papers from the ISAC task group, whereas we have 6 white papers, topical white papers from the network architecture task group. Okay, and as far as the umbrella white paper, ICDT, deep convergence, deep integrated 6G network. This is actually, in parallel to the fact that this is the 5th global 6G conference. This is also the 5th version 5 of this white paper. So building on the previous foundation, there is further enhanced 6G framework discussion, key technology coverage, and also highlighted a few important industry applications. In particular, you will hear a lot, I think, for the whatever remaining time today, which is the digital low altitude economy. Okay, now, First, the ISAC task group, which is headed by Jing Jing, together with a lot of ISAC technology ecosystem players, jointly they delivered 3 topical white papers focusing on different aspects of ISAC, going from covering the requirements, the basic theory, the technology, engineering implementation, standards, impact, industry consideration, the progress, as well as ecosystem status and outlook. The first one actually is empowering digital low altitude, ISAC. Okay, here, first of all, it's addressing an incredible $1 trillion market, which is a rare find in our industry in recent years. So it's very precious. And this particular white paper looked at 5 main challenges, from theory to coverage, accuracy, reliability, and interference management as key technical challenges, and also offer some potential solutions, as well as looked into the standard impacts and also shared some field trials results. And the second ISAC paper focusing on base station collaborative ISAC. And it looked at some fundamental information theoretical limits in this particular setting, and focused on some intelligent management and also high precision synchronization solutions. And it also delivered a shared prototype with multi-persons breathing detection in the same environment, and showed the advantage of doing signal fusion versus parameter fusion. And the third ISAC paper is looking at different scenario where it's base station together with UE to collaborate, the collaborate ISAC, not between base station. So in this particular white paper, it offered proposed actually the protocol stack consideration and the necessary process flow of such a scenario. Okay, the second task group, the network architecture task group, is headed by Sun Qi. Here, this year, we have 6 topical white papers. One, again, complementing the ISAC white paper on digital low-altitude economy. We have an architecture white paper for the digital low-altitude economy. This is kind of a new scenario. And in addition, there are a couple architectural consideration on new RAN proposal, and then one on the core network, and then on an end-to-end user plan proposal white paper, as well as a consortium network that looks across heterogeneous collection of different type of network. Okay, I have to fly very quickly. I think one sentence each paper, okay? So for the one on the network architecture for the digital low altitude, this one actually is quite comprehensive. It looked beyond just sensing, of course, look at communication, sensing, and computing needs, as well as the security consideration. And actually, it's covering, I think, a little bit above the low altitude, because it goes all the way up to 1,000 meter. I think the actual digital low altitude where we would start is probably somewhere between, up to 300 meters and maybe up to 500 meters. But 1 kilometer, to me, sounds a little high. That's why the architecture that's proposed here involves not only terrestrial network, but also satellite network to complement it. And then the one on the user plan actually is focusing on the programmability which would be needed in order to deliver integrated communication, sensing, AI, and computing services in the future 6G network in efficient, flexible, and intelligent manner. And particularly, it proposed on-demand protocol stack, and also, of course, service-oriented functional decoding, and AI-driven, that is, goes without saying. And then for the consortium network, it's an interesting kind of macro perspective, where it's looking at how satellite network, terrestrial network, and the industrial special purpose network, or even other private networks, how they could be interconnected and provide efficient resource sharing as well as maybe service trading across these multiple networks that we expect to coexist in the future. Okay, the one on the core network is pretty much extending what has been already started for 5G network, which is a service-based architecture, intelligence element. Of course, the 5G only has a MWDEF, but here the intelligence element is going to become much more comprehensive, and also cross-layer optimization, considering semantic communication opportunity in such a setting. Okay, and then the next two are about the RAN. The first one is called a fully decoupled RAN, which in a very peculiar way, it is decoupling control and data sets, actually, a base station. So it's conceiving. It says I have 4 minutes left. Okay. So the base station would be divided or categorized into control base station, or uplink data base station, and downlink base station. It's conceived that you could use the low frequency band for the control base station, whereas the uplink base station could be built with low cost and with a high density deployment, whereas the downlink base station would be massive MIMO based. But I think in actual environment, how this would actually work as an overall network, the management and control will require still a lot of thinking. So it's an interesting thought. And the next one about RAN has a similar idea. It's also trying to decouple downlink cells and uplink cells. Also, it further by saying that we can actually pool cells or I think radio heads as well as carriers in a more flexible manner across different base stations. I think both of these are highly related, and maybe next year we will have a combined white paper as a phase 2 of these two. Okay, now our 6th version of quantum information technology white paper is included in this collection. And this year there is a lot of interesting progress, both for the post-quantum cryptography and also quantum distribution. Particularly, it is expected that the PQC standards will be adopted in 3GPP raise 20, and I think we'll have to check and confirm with some of our 3GPP chairs that are present here. And also, the metropolitan scale QAD will be actually into a pilot commercialization phase this year. This is the latest information on that date. And also there's some interesting success of using the quantum machine learning for fields that's highly related to our industry, which include the radar signal recognition and also the network anomaly detection use cases that was shared here. Now, immersive communication, in this particular topic white paper, it goes from the requirements in multiple dimensions to the key technologies that comes from covering both device technologies, the media processing technologies, the codecs about video, audio, tactile, etc., and also the network technologies. It's interesting, I think, overview paper for you to take a look. And next is the space ground. This particular one is also a second version of this topic. This time it shared, based on experience of the success of SMS and voice communication in the GEO satellite, and bring some lesson and learning to the future LEO and MEO system design, both from the hardware, the network, and the radio aspects. Okay, and this one is on upper 6 gigahertz band, which, as you can see on the upper right-hand side, it's right now has almost global, is almost globally harmonized since World 23. However, the yellow area is still making an effort. So this one, I think, is sharing some of the trial results and some of the spectrum auction results that happens in different parts of the world. And hopefully, soon, we will have a globally harmonized, generally true, so it will be all green. Now, the near field, I have to specifically highly recommend this particular topical white paper, not only because it is the thickest one, if you look at our deck. It's actually, you can see, this is through the labors from more than 250 contributors from more than 80 organizations and from 17 countries, okay? So most of our topical white papers are actually having co-authors in a global distribution, but this one in particular, I think, is really a flagship representation of how global our community has become. And this covered the latest progress, both in terms of the field trial and also engineering implementation, and also standards impacts consideration. And especially since the near field is really still kind of new for our industry, this one offered 14 application scenarios and provide a very comprehensive theoretical and technical framework for near-field communication. Okay, I guess there's a group trying to kick me off. So let me very quickly, the next three topical white papers are all about RIS, reconfigurable intelligence services. First one is about the channel modeling. Second one is initial consideration of standardization impact, considering full transparent, half transparent, not transparent versions, and also network control versus the UE control. The third one, personally, I think maybe the most interesting one of the three, because this one offered a lot of experience and progress that the industry interested in RIS has made. Particularly, you'll see on the right-hand side, areas scenario for indoor, and a large variety of outdoor as well. So I think it would be very interesting. You have time to take a good look of this one. Okay, finally, last but not least, CCFD. How many people remember when we heard this the first time? The full duplex, co-frequency, co-time. This actually was a very hot topic more than 10 years ago, at the beginning of the 5G research, R&D. It made a lot of progress, got a lot of attention, and also some hard challenges. So this one, I think, is the latest, the greatest, all the progress in research, in engineering, and also consideration on related standards and patterns, and integrating with additional technologies such as MIMO and RIS, and also considering its application in the LEO satellite scenario, considering its usage with full duplex caching as well as relay. So it should be a very interesting white paper to take a look, because it's a kind of accumulation of progress from the past 10 years, I believe. Okay, finally, again, this is a page that I used in the first global 6G conference, again, in year 2000, when we had the 6G series for the first time. And all the keywords there, I'm not going to read. I think you all agree with me. We are on the right track altogether. And next year should be exciting because we will have a better idea of what 6G will be like by then. Okay, so with this, I want to invite all the co-authors and leaders of our Series 11 topical white papers, as well as umbrella white papers, co-authors come on the stage. So we are jointly release this collection.
谢谢易老师，祝贺6级工作组。
Thank you. Congratulates. Now, we're going to give the floor to Yan Li, Chairman of the Vehicle Networking Working Group of Future Forum, Global Vice President of Qualcomm, to release the white paper on vehicle networking series. Thank you. Very glad to be here to release the white paper of my work. The Vehicle Networking Group is a cross-disciplinary team. Probably you pay attention to the mobile network, but for the vehicle networking, we have a lot of cross-disciplinary approaches. Today, I'm going to release 3 white papers. I'm going to be very quick. I'll be honest with you, because this is a cross-disciplinary approach, it is going to be very difficult to be understood. The first white paper is that we have been applying LPS on autonomous driving or providing alerts to the driver. A very important thing is that how do you make sure that what is the scope of that vehicle that is operational. So this particular white paper is pretty much vehicle-oriented. What is ODD? Recently, you've been seeing some accidents about autonomous driving. So when you apply AI in the autonomous driving area, as we have mentioned, that please do not actually believe that AI is almighty, and we have to put AI in a cage, and the AI is not operational when it's outside of the cage. So the AI has to know the scope of work. If not, we have to control this with actual methods. So for ADD, that when we apply in the LTV V2X to this vehicle, what is the working scope? Also, these are the yellow parts and the blue parts. We have to define the scope of the yellow and blue circles, so that we have to make sure that the working scope of autonomous driving could be enlarged, and also at the same time we might find some of the pre-existing risks. So you don't need to overly trust the functions and features. Also, some of the areas impacting ODD, for instance, the communications-related, legislation-related issues, and also we finally cut it into slices of 10 or so, and discuss upon them one by one. In the white paper, we have come up with certain scenarios, for instance, the crossroad clash, and some of the others. The final conclusion is that we have a whole suite of vehicle engineering analysis, and the final conclusion is that LTE V2X-based application-specific scenarios are helping us to enlarge the boundary of ODD, and also we need to have certain limitations and certain areas, and also optimize certain algorithms. The second white paper is quite simple, which is related to communication, sighting, ranging, and positioning, which is a direct communication in between different devices. Not only we need to establish a communication, between human and devices, but also we need to introduce the positioning and range and capability in between different devices. Not only we could apply this on the telematics or the vehicle networking, but also it could be used on smart home and the tracking of objects. In the vehicle networking, very important area is that how that we are able to make sure that the vehicle is not hitting the VRU. We're talking about pedestrians and two-wheels bicycles, because these VAUs are moving very slowly and the object is quite small, so it's very difficult for the vehicle to observe and identify. So if we can have the side link and introduce this to this, we could actually provide the range and positioning testing, and this is able to actually increase reduce the risk of the crash and accident. So 3GPP has conducted a summary with regards to sign-link, including RDT, TDOA, VOA, etc. And these are the SL pose methods, and also how that we are able to integrate those technologies into sign-link. And this is a very good white paper describing the work of sign-link by 3GPP. On the third day, we have this functional safety analysis of CV2X warning applications. So we want to confirm the feature is safe. So function safety is a very much engineering related topic. It's not about the vehicle safety itself, and it's not about the data security or cybersecurity. It emphasizes that when there is a regional failure or local failure, the whole vehicle itself will remain operational. So, of course, failure happens within the vehicle, but also for CV2X, we might involve multiple vehicles. The kind of working methodology is ISO 26262, and we analyze the relevant components and also define the HISO, which is a level of risk, and we set up the security objective for each different rating of the risk, and provide the conclusion and also results. So we have analyzed several scenarios, and the conclusions are that, first of all, it is important. So if there's a misalarm, false alarm, these are not very important, because when there's a misalarm, we still have driver behind the wheel. But false alarm is very, very dangerous, because when there is a no accident and you have a false alarm, and the driver may hit the brake all of a sudden, which may cause a rare clash. So we have to avoid that. But from a V2X standpoint, this is a assisted driving system, and even if there is a false alarm, the driver is the accountable person. So the ASO QM is the lowest, which means that you don't need to have a lot of recover. Also, we came up with a conclusion that today we have analyzed on three different cases, but can extend that to another 17 scenarios. All the conclusions are that if this is scenarios or use cases related to the alarm provided to drivers, this could be regarded as the ASO QM. Also, I'm very grateful to Xingyun, Starlink, and also Oppo and Qualcomm, and also the rest of the other 23 companies of joining us. So now I'm going to invite the key representatives of those companies to all together join me in releasing this white paper. Thank you very much. Congratulations on this wonderful achievement. And now I'm going to give the floor to Qi, Chairman of the Digital Low Altitude Working Group of Future Forum, Chief Scientist of China Telecom, Bell Labs Fellow, IEEE Fellow, to give us a release of the white paper Digital Low Altitude series. Hello everyone, on behalf of the Digital Low Altitude series working group, we are now announcing the white paper series on digital low altitude. We all know that now UAV and logistics and eVTOL commute have already become hot topics in this area. Not only do we see the self-development of self, but also it is also helping to promote the development of 5G and 6G technologies. Future Forum last year in August, we had working group on low altitude series formed and established. So, China now has a leadership positioning in altitude economy. Also, on this working group, we have accumulated hundreds of different experts throughout China. And the industrial chain of the low altitude economy is quite long, with many different specialists and experts involved. So, with concerted efforts of everyone, we've been doing a lot of works already, but still within a short period of time, I think it was a great effort paid by everybody. And around the area of latitude economy and frequency, and also the working architecture and the security-related issues, we had actually a deep research. And also today, I'm very glad to hear release 7 white papers on digital low altitude series, including the scenario and application and communication requirements, and low altitude evaluation white paper, and white paper on ISAC, white paper on the network architecture, and also the ubiquitous security-related safety and security system, also low altitude monitoring, and also weatherness technology, and finally we have the test and verification related white paper. So I think that all the kind of different white paper is the result and also the final product of concerted efforts of everyone. So I'm very much glad to invite the people involved in those 7 white paper compilations to join the stage to altogether join me in releasing the 7 white papers. All right. Thank you and congratulations on all the experts. So for the future forum, all the working groups in the past 1 year achieved a lot of results. But now, I think that I hope that all the works conducted by the working group could be more and more efficient. Of course, we hope that we can have 2 new working groups formed. The first one is the self-free network working group and new mid-band working group. I would like to invite the initiators of these 2 working groups to be on the stage to witness this launching ceremony.
工作组正式。
Congratulations. Also, I would like to welcome everyone to actively participate in all the researches conducted by different working groups. Very last item of the agenda, which is the most important session of today. We're now having the awarding ceremony of 2025 Global 6G Conference 6G Rising Star Young Scientist. I think that this year we've been receiving a lot of participations. So after a jury member's judgment, we've got 20 scientists getting the awards of a 6G Rising Star Young Scientist. They are Ma Shuai from Pengcheng Lab, Wu Qingqing from Shanghai University, Gao Zhen from Peking Technology University, Yang Jianyan from Zhejiang University, Zhang Chuan from PML, Liu Lei from Zhejiang University. From Chinese Academy of Science and Technology, Liu Yaoqi, Zhang Jiao from PML, Hong Kong University, Liu Yanwei, Tang Pan from the Post and Telecommunication University of Beijing, and Pan Cunhua from China, Hong Kong Chinese University, and Zhong Yi from Central Huazhong University of Science and Technology, and from Southeast University, Pan Cunhua, and Zhou Suhui, and from Maxi University, Feng Chenxue, from the Electronic Scientific Technology Company, Yanggang, and Cao Jing from Xi'an University of Science and Technology, and Ding Shenli from Vivo Communication Research Institute. Now we have 20 young scientists standing there right on the podium, and please joining us in giving a round of applause to those winning young scientists. Now I would like to ask the Mei Jianping, Xi Jian, Yu Jian, Wu Jianjun, and also Vice Secretary General to present the certificates of winning to the young scientists on the stage. Ladies and gentlemen, the opening ceremony of 2025 Global 6G Conference ends successfully now. Thank you very much for your sharing, and we have more sub-forums waiting for everyone that are as exciting as today. Please keep tuned on this particular 6G Conference of 2025, Better Together, Better Future, and thank you very much for contributing your thoughts.